We're given the line y is equal to mx minus 2, and this line must be cutting the graph at two distinct points. If I were to look at this line, it has a constant y-intercept, and that is at 0, minus 2. So 0, minus 2 can be a point that is, let's say, somewhere here. And if I were to draw a line that will be cutting the graph at two distinct points and passing through this, it can be a line that looks something like this. Okay, a straight line that is going to be cutting the graph at two distinct points. But m can change. And by changing m, this line will be swinging upwards or swinging downwards and at the same time pivoted at the point 0, minus 2. If the graph swings upwards, it will still continue to cut the graph at 2 points. One point will be somewhere along here. The other point will just go further and further away until when this line swings to a point where it's synchronized to this other line. Let me draw it for you. It is going to pass through 0, minus 2 for this other line, and it is going to be parallel to this. So the moment when this happens, parallel. So let's say something that is like this. The moment when this happens, that means this line y is going to mx minus 2 will be cutting the graph at only one point. Okay, anything that is more gentle than this line, it is going to be cutting at one point, and the other point is going to be high up here. So what we need to do, I'm going to call this line here line A, is to find the gradient of this. And the gradient of this line is not going to exceed the gradient of this. So for the gradient of this, I'm going to make use of the original equation. For the original equation of the graph y is equal to modulus 7 minus 2x. If I were to remove the modulus, it is going to be plus or minus 7 minus 2x. So we have two lines. One will be minus 7 plus 2x. The other one will be 7 minus 2x. Y is equal to this. Y is equal to this will make up this modulus graph. And if I were to match based on the gradient, this has a negative gradient, so it must be matched to this. So which means that this part of the graph of the modulus will be y is equal to 7 minus 2x. And this has a positive gradient, so it is going to be matched to this. So this will be y is equal to minus 7 plus 2x. So 2x, this 2 will define for me the gradient of this line, which is going to be parallel to this line, which means that the gradient of this line will be equal to 2, which means that for the gradient of the line A, we can observe that it is equal to 2. So m should not exceed 2, or else it is going to, this line is not going to cut the graph at 2 points, two distinct points anymore. It is going to be cutting at just 1 point. Next, I'm going to focus on another line if I were to swing this line downwards to make it more gentle. And if I were to swing it downwards, yes, it is still going to be cutting at 2 points until when this line is such that it is going to synchronize to this other line that passes through this point and this point here. So it must be a line that passes through these 2 points. And we can see that it will start to cut the graph at 1 or less, no more points. Okay, because if it is this, it is going to be cutting at 1 point. If we were to make it even more gentle, there will be no intersection at all. And I'm going to call this line B. And this will define for us the smallest possible m should go before it is going to stop cutting the original graph at two distinct points. So in order for me to find the gradient of this line B, I'm going to find this point, the coordinates of this point. So to find the coordinates of this point, we are going to let y of this graph, this original graph, be equal to 0, which means that it is modulus of 7 minus 2x. This is equal to 0. X is equal to 7 over 2. So the coordinates of this point here is 7 over 2, 0. And let's find the gradient of this line B. So the gradient of this will be 0 minus minus 2. So 0 minus minus 2 divided by the x coordinate, which is 7 over 2 minus 0. And this gives us a 4 over 7. And like what we have discussed, this green colored line will have a gradient, but this gradient must be between the gradient of this and the gradient of this. So the gradient, this m here, must be between these two. This is a smaller gradient. It is 4 over 7. And this is the bigger gradient. This is 2. And this is what the question wants us to show.